What makes something an acid is if it ionizes when you put it in water, and it gives you H plus ions. So you see here, I've said H plus ions, right? A positive hydrogen. Now let's just talk about a positive hydrogen for a little bit. What would a positive hydrogen ion look like? To answer that question, you must ask yourself, well, what would a hydrogen look like before it was an ion? So before it was an ion, it was a hydrogen atom. So you're either working on the notes by hand or on the PowerPoint. What does a hydrogen atom look like, guys? The atom. The atom doesn't look like an H. What does the atom look like? Sorry? And what's in the nucleus? How many protons, how many neutrons? One what? One proton. And then one electron. So a hydrogen atom is literally one proton being orbited by one electron. So what's a hydrogen ion? No? No? Sorry? 2 electrons. But why is it positive? It's H plus. One proton and no electron. So a hydrogen ion is basically a single proton. Right? You might want to write it on there somewhere. I'm going to do it quickly. I'm going to say here H plus ion, which is basically, I'm going to call it a naked proton. We don't call it naked. Just say one proton. Now, you could, if you wanted to, call it a naked proton, but it's basically just one proton. One proton all on its own with no electron. It's lost its electrons, and it's just a single proton. Right? That's what it. Now, what am I saying there? I'm saying an acid ionizes in solution to give you a naked proton. An acid ionizes in solution to give you naked proton. So when you put an acid like HCl, I've just told you that hydrochloric acid is an acid. If you put that in water, look what happens. The hydrogen ion comes off, and you're left with a hydrogen ion and a chloride ion. What's happened to the hydrogen's electron? It's gone where? To the chlorine. The chlorine has taken the hydrogen's electron. Okay. Now, next to that, I've written 100%. The reason I've written 100% there is because for hydrochloric acid, every single hydrochloric acid molecule that you put in water will ionize immediately. And that's why we call it a strong acid. Okay, because all the molecules ionize. So it's basically 100% of the HCl molecules will ionize. Writing it in that first reaction is actually a bit of a simplification. I've then written it like this. I've said HCl, I've put plus water in brackets. What actually happens is this. It reacts to form an H3O plus and a Cl minus. That H plus ion will never exist in water on its own. A naked proton is never going to float around in water on its own. Its charge density is too high. So what it does is that proton actually jumps onto another water molecule. And it makes what we call H3O plus. Now, H3O plus is called the hydroxonium ion. But we very seldom show it like that. We normally draw it like this. Even although that's not true. Why are we writing things that are not true? Because we know what we're doing. If you know that H plus is actually not H plus, it's H3O plus, then you can write it like this. Yeah, I've said it before. If you know you're talking nonsense, it's fine. So when you write down HCl goes to form H plus plus Cl minus, you're actually talking nonsense. This is actually what's happening. Right? The hydrogen ion, I'll come to you in a second, joins up to a water molecule and makes H3O plus. But we very seldom show that because it's just too complicated. We just show H plus. Whenever you see H plus in your mind, you must be saying H3O plus because that's what it is. Question? Is there no more? Yes, there are. Yeah. Okay. And did you get these as well? All right. So that happens for all of the acids. So some of the acids I showed you now, nitric acid, what does that do? It breaks up to give you H plus and NO3 minus. No, so actually it's H3O plus. Yeah, it is. Right? What happens to sulfuric acid? Well, sulfuric acid is H2SO4. It can actually break up to give you 2 hydrogen ions. And what would be left if 2 hydrogen ions come off the H2SO4? SO4, 2 minus, write it down. You must be able to write these dissociation reactions for any acid or any of the acids that we've studied. So that's 2H plus. If 2H plus ions come off, you get an SO4 2 minus. Now, I've got the name of these anions here. Now, you should know these names because you did them in grade 9. NO3 minus is nitrate. SO4 2 minus is sulfate. I've written down here strong and strong. Basically, I'm telling you that these are 2 strong acids. Right? Carbonic acid. What's that formula? H2CO3. That can also give you 2 hydrogen ions. And it forms the carbonate anion. Now, that's a weak acid. That's why I've put 2 arrows here, one going forwards and one going backwards. Because that reaction does go both ways. To be 100% honest, all acids and base reactions are reversible. All of them go backwards and forwards, but the very strong acids hardly any go backwards. So for the weak acids, we'll show it as an equilibrium, going backwards and forwards. Ethanoic acid, the vinegar that I showed you, its formula CH3COOH. Learn more about that when we've done more organic. It can give you 1 hydrogen. Only one of those hydrogens comes off, this last one. That one there comes off. And it's also a weak acid. That's why we show it as a 2-way arrow. And the anion formed is called the ethanoate anion. And that's a weak acid. We're going to expect you, gentlemen, to know the formulas of all of these, to be able to write these dissociation reactions, to know the names of the anions, and to know whether they're strong or weak. Yep. And the ones in the notes. Yeah, there's a few more in the notes. All right. So that's just some introduction to acids. Okay, can I move off that? Good. So now we're going to go and look at bases. A few common bases. What is a base? Well, it's something that's going to neutralize an acid, and it's going to form salt in water. Come on. This PowerPoint is taking forever now. I don't know why. There we are. A base is going to neutralize an acid, and it's going to form a salt plus water. Right? That's one of the reactions you have to just learn. Bases neutralize acids forming a salt plus water. Just have to learn. What's a salt? I've written it here. I've scribbled it in pen. I don't know if you can read my not so neat handwriting. A metal and a non-metal. That's what a salt is. And the bases do this by accepting the hydrogen ion from the acid. So here's an example, sodium hydroxide reacting with HCl. What happens? You form sodium chloride, table salt, and water. Now we're going to expect you guys to be able to write these kind of reactions as well. Right? The other base, one of the other bases I showed you in ammonia. How does that react with an acid? Well, ammonia could react with, say, for example, nitric acid. It accepts the proton. So you can see the hydrogen goes from the nitric acid onto the NH3 to make NH4. But now it's plus because the hydrogen brought its plus charge with it. So it makes NH4 plus, and then you're left with the nitrate anion, which came from the nitric acid. Right. Another one, hydrofluoric acid, HF. Could react, say, for example, with potassium hydroxide, which is a base. It would make the salt, potassium fluoride, and water. All, say again, KF, potassium fluoride. Now, you obviously didn't learn the names of all the elements up to 20 in grade 8. Did you? So then you should know what KF is.
I thought the object was the split.
Oh, okay. Okay. Last one. Carbonic acid plus potassium hydroxide, making potassium carbonate and water. Okay. You've got to be able to write all those reactions out. If I give you the acid and the base, you should be able to write the product. And to be honest, if I give you the products, you should be able to write down which acids and bases they are. We're going to practice some of those in a minute. So what do bases do? Now, there's two definitions of bases, which I've set out for you nicely in the notes. We'll go through them a little bit. I've basically kind of got both of them on this page. Bases give you OH minus ions. They give you hydroxide ions when you put them in water. The acid thing as well. Remember we said, what's an acid? It gives you what? Gives you H plus ions. When you put it in water. Okay, that's all the acid-base reactions take place in water. Acid, anything that gives you H plus ion when you put it in water. A base, anything that gives you an OH minus ion when you put it in water. So how do they work? Here's a few examples. Ammonia, if you put it in water, gives you NH4 plus and OH minus. So there's the base nature, right? Sodium hydroxide, put it in water, you get sodium ions and hydroxide ions. Now, I've put the water here in brackets because it's not a reaction. It's just dissolving. Okay. So the sodium hydroxide has gone from being solid. You can see the S there. It's got an S over there. And now on the other side, you can see it's got AQ. AQ stands for aqueous, dissolved in water. Right, so that's not actually a reaction, but it is giving you OH minus ion. Calcium hydroxide would do the same. Magnesium hydroxide would do the same. Now, another little discussion we need to have. We're using a different word. Well, I haven't actually used it. There's a different word that we use with bases than the word that we use for acids. Here, I'm saying that these bases dissociate. Right? Here's the word here. These bases dissociate. With the acids, I used a different word. What word did I use? Ionize. Why did I say the acids ionize and the bases dissociate? Anybody got an idea? I'd be very surprised if you did. Okay, so let's go back and look at the acids quickly. I don't know why my computer's slowed down so radically. I'm just going to go back to the acids. Might take me 10 minutes to get there, but I don't know why. Why is my computer going so slow? Let me just see if I can fix it quick. Hey? Got too many tabs open. Would I ever have too many tabs open? Should we just see if Musenberg is breaking? It is actually fine. Oh, yes. All right, so let's just close that. Maybe that will help. It's all right. They're all open again every time. So if I go to acids, that hasn't sped up my computer at all. Why am I saying ionize with the acids? Talk to me about the bonding in HCl. Spot on. How does he know it's covalent? Two nonmetals. Okay. Now, I said it ionizes. So a covalent substance is making ions. Tell me, are there any ions in the covalent substance? No. If there were ions, it wouldn't be covalent, it would be ionic. So the ions are actually formed in this reaction. That's why we said ionize. But if we go to the bases, what can you tell me about the bonding in something like sodium hydroxide? Come on, you know where we're going now. It's already Ionic. How do we know it's ionic? Metal and non-metal. So are the ions formed in the reaction, or did they already exist? They already existed. So with bases, we don't say they ionize, we say they dissociate, because the ions already were there. They just don't sit by each other anymore. All right. Okay, it's a small technical point, but you might as well get it right. So that's what I've explained on this page. Have you got this page? Okay. So that's what I've explained. On the left here, you can see I'm talking about ionization because you have a covalent molecule, no ions. I've just scribbled that with my hand. I hope you can read it. Two nonmetals, covalent bonding, but the ions are actually formed, therefore it's ionization. But with the bases, it is already ionic. The ions already exist, so they just separate. All right. Good, yes. Covalent molecules. Covalent molecule. Okay. Now, bases. Let's talk a little bit more about bases. Gentlemen, all these things in this table are actually bases. So bases, there are different kinds of compounds that can be bases, right? Here are 5 of them. A base can be metal hydroxide, which is the one on the left there. A metal hydroxide is a base. A metal oxide is also a base. Metal carbonate is a base. A metal hydrogen carbonate can work as a base, and ammonia is a base. Right? All of those can be bases. Now, what I want you to do, you should, from grade 9 science, be able to write out those formulas. Have a go quickly. What's missing here? Calcium hydroxide. What's missing there? How do you know? The CH2 plus. How do you know? Group 2. Do the rest. Quick. Now, the statement at the bottom, might want to write something there about it. I've said that soluble bases are called alkalis. What am I talking about there? You'll often hear people talk about bases and talk about alkali. What's the difference? Some bases are not soluble. They won't dissolve in water. So a lot of the oxides are not soluble. Aluminium oxide, for example, is not soluble. That's Al2O3. Now, if you want to make a note of this somewhere, it's good knowledge to have. Aluminium oxide is not soluble. I don't think calcium, calcium oxide might be slightly soluble, but a lot of the oxides are not soluble. Most of the hydroxides are soluble, but there's 1 or 2 of them that aren't. So manganese oxide isn't very soluble. And magnesium oxide is not soluble. Calcium carbonate is limestone. Is that soluble? Not very. So if a base is not soluble, we just call it a base. It's not an alkali. But if a base is soluble, like sodium hydroxide, calcium hydroxide, then we call it an alkali. Okay, so you just need to know the distinction between those. Can I move off that slide?
So what did you say is called if it's not soluble?
If it's not soluble, it's just a base. But if it is soluble, it's a base and an alkali. Okay. Right. So here's a few reaction of bases. So there's a few of the bases I've taken off the top there. And I'm just showing you how they react with acids. So here's calcium oxide reacting with HCl. It makes calcium chloride and water. So if you remember, I said to you before, the reaction with acid and a base makes a salt plus water. So this one, I've written half the reaction. Calcium carbonate plus sulfuric acid is going to make the salt calcium sulfate plus water. I've left the water off for you to write on. Now, for this one, I haven't done anything. Sorry? Oh, sorry. That's a good question. It makes water and carbon dioxide. This one with the carbonate, thanks for pointing it out, makes water, calcium sulfate, water, and carbon dioxide. This one is also going to make a salt plus water and carbon dioxide. A hydrogen carbonate also makes water and carbon dioxide. But what's the salt going to be? Where does the metal in the salt come from here? There's the salt. Where does the metal in the salt come from? Ca comes from the acid or the base? Base. Where does the Cl come from? The acid or the base? So the metal part of the salt comes from the base. The non-metal part of the salt comes from the acid. So the metal part of the salt comes from the base. So which of these two is the acid and which is the base? NaHCO3 is the base. So the metal is going to come from the base. So the metal is going to be Na. So start writing here, Na. And the non-metal part comes from the acid, PO4. Now, what's the charge on PO4? 3. So I've got 3 hydrogens there. So if you needed 3 hydrogens, how many sodiums are you going to need? 3. Na3PO4 plus 3 carbon dioxides plus 3 water. So you're going to have to work on these. Now I've done the bottom one for you. Ammonia and nitric acid just makes ammonium nitrate, and which is NH4 plus and NO3 minus. So that's just a few reactions of acids and bases. Now, next lesson we need to do a whole bunch more.